You know the feeling. You settle onto the couch, you hit play on Netflix, and your show just starts instantly. But what really happens in those milliseconds after you click? How can one service possibly stream thousands of different shows to over 125 million people all at once without ever crashing? Well, today we're going to pull back the curtain on the incredible invisible technology that powers your nightly binge watch.
To even begin to get your head around the scale of this, just look at this number, 1.3 petabytes. That is the tidal wave of data Netflix ingests every single day. And we're not just talking about what you watch. It's every click, every search, every pause, every little error log. I mean, that is a mind-boggling amount of information to manage. So, that brings us to the big question, right? How on earth does a system juggling that much data for that many people work so flawlessly? The answer is actually a really elegant three-part process: preparation, personalization, and delivery.
Let's start at the very beginning. Part 1, preparation. The journey of your favorite movie doesn't start when you open the app. Nope, it starts much, much earlier. From the moment a production house delivers a single, absolutely massive movie file to Netflix.
And right away, here's the first huge problem they have to solve. That one master file, which can be around 50 gigabytes, is totally useless for streaming. Think about it. It's way too big, and it has to work perfectly on your giant 4K TV, your laptop, and your tiny phone screen, all while dealing with your super fast home internet or that shaky coffee shop Wi-Fi. One file just isn't going to cut it. Their solution is a process called transcoding. Basically, Netflix takes that one giant file and creates hundreds of different versions of it. Each one is perfectly tailored for a specific combination of screen size, device, and internet speed you could possibly have. But converting all those files one by one would take forever. So instead, they use this incredibly clever parallel pipeline. They take that massive source file and chop it up into small chunks. Then, thousands of virtual servers in the cloud process all those chunks at the exact same time before stitching them all back together into hundreds of new, optimized files.
So what's the end result? That one single movie file becomes around 1,200 different files. And this is the secret sauce that enables something called adaptive bitrate streaming. That's the magic that lets your video quality seamlessly drop from crystal clear HD to standard def when your Wi-Fi starts to stutter, saving you from that dreaded buffering wheel. It's not just a technical trick, it's fundamental to keeping you watching. Okay, so now we have 1,200 versions of every single show and movie all ready to stream. That brings us to Part 2, personalization. How in the world does Netflix decide which of those thousands of titles to even put on your homepage in the first place? Well, this is where the brains of the operation really kick in. Now, here's a key piece of the puzzle. Netflix basically operates in two separate clouds. All the thinking, your login, your recommendations, your search results, everything that happens before you press play, that all happens on Amazon Web Services, or AWS. The actual video files, though, they're streamed from somewhere else entirely, and that separation is absolutely critical for speed and reliability.
To power its recommendations, that AWS backend is constantly learning from your behavior. It's tracking what you watch, what you search for, what time of day you watch, the device you're on, and most importantly, it's comparing your tastes to millions of other people who are just like you.
And it mainly uses two types of algorithms to do this. The first is collaborative filtering, which is a fancy way of saying, hey, people who liked what you liked also like this. The second is content-based filtering, which is more straightforward. You watched a lot of action movies, so here are some more action movies. When you put them together, they get scarily good at predicting your next favorite show.
But, and this is where it gets really wild, the personalization goes even deeper. It's not just what shows you see, but how you see them. I mean, check out this quote from their own engineering blog. Even the thumbnail images, the artworks, are personalized specifically for you. So here's how that works. For a single show like Stranger Things, they might create 9 or 10 different thumbnails. Then they run a giant A/B test, showing different images to different people and measuring which one gets the most clicks. The winner then gets shown to more people. It's a massive, ongoing experiment to find the one image most likely to make you press play.
So, the movie is transcoded. The recommendation engine has picked the perfect show and the perfect thumbnail to grab your attention. You click it, and now we get to the magic moment, the instant stream. And it's all powered by Netflix's secret weapon.
That secret weapon is called Open Connect. This is Netflix's very own custom-built content delivery network, or CDN. You can think of it like a private internet, with thousands of servers planted all over the globe, designed and built for one single purpose: streaming Netflix video to you as fast as humanly possible.
To really get why this is such a game changer, think about the alternative. Without it, your video request would have to travel across the country, maybe even across the world, from some huge centralized data center. And that travel time creates latency, which is just the technical term for lag and buffering.
But with OpenConnect, Netflix does something brilliant. They physically install their own servers, packed with every version of every show, directly inside your local internet service provider's building. That means the movie you want to watch is literally located just a few miles from your house, not a few thousand.
The advantage is just massive. By dramatically shortening the distance the data has to travel, OpenConnect absolutely crushes latency and practically eliminates buffering. Honestly, it's the single biggest reason your stream starts instantly and why you stay a happy customer.
Okay, so we have content that's prepared, personalized, and delivered at incredible speed. This brings us to the final, crucial piece of the puzzle: resilience. How does Netflix keep this unbelievably complex system from just breaking down?
You see, Netflix's backend is built on what's called a microservices architecture. Instead of one giant application, every single function, like search or billing or recommendations, is its own tiny independent service. But when you have thousands of these things all talking to each other, a failure in just one could trigger a catastrophic domino effect. To stop that from happening, Netflix built an amazing tool called Hystrix. It works just like an electrical circuit breaker in your house. If one of those little microservices starts failing or slowing down, Hystrix trips the circuit, isolating that failure so it can't bring anything else down with it. It protects the whole system.
And this is all part of their larger philosophy of resilience. They use Hystrix to contain failures. They design their services to be stateless, which just means any server can handle any request, so there's no single point of failure. And they separate the most critical functions, like the play button itself, so that it has as few dependencies as possible, making the whole system incredibly robust.
And that is the entire journey, from one single file becoming 1,200 different versions to a recommendation engine that knows exactly which thumbnail you're most likely to click, all the way to a server sitting just a few miles from your home. It's this massive, complex, and incredibly resilient global system, all engineered for that one simple moment when you press play. So, the next time your show fires up without a single second of buffering, you'll know about the incredible chain of events that made it possible. And it really makes you wonder, doesn't it? What other invisible, complex systems are hiding in plain sight, powering the rest of our daily digital lives?